Here's my tutorial video for the question trail hints Fakie test. So remember, you can hit pause at any time, so I'm not going to go all that slowly because you can always just pause and rewind to your heart's content. So here's our reaction. We have 6 atoms of carbon and 8 atoms of oxygen. That's 8 sets of 2. We have sets of 2. So if 2 of these will get you 2 of those, then say 19 of these will get you 19 of those, and 6 of these will get you 6 of those. If one of these will get you 2 of those, then this number will be double whatever you just said for this one. And 5 will get you 10, and 10 will get you 20, and 8 will get you 16. At this point, we cross out the impossible number. The big number is always wrong. It's always impossible. And so which would run out first? The one that makes the reasonable amount would run out first. Remember, we can't make 16 of this, which means we have extra of that. So the other one runs out first. It's the limiting reactant. For number 2, we have 3.5 moles of aluminum and 5 moles of oxygen. So 4 will get you 2, in which case you'll get half as many moles of this as you have of that. And I say it that way because that's what we were given here is moles. We don't have to convert to moles, we have moles. Your destination, where you're going to on top, where you're coming from on the bottom, plus I told you there. So it's 2 of these for 4 of those, 2 and 4, which again means you'll get half as many. In this case, for the oxygen, you'll get 2 for every 3. So it's 2 for these and 3 of those, 2 and 3. Multiply by the top, divide by the bottom in both cases, and we get 3.33. Choose the one that's possible. Again, it's the small one that's possible. The big one is impossible. On 3, we're asking what remains. If we have 8 sulfurs, what can we make of SO3? If 2 will get you 2, then 5 will get you 5, 7 will get you 7, and 8 will get you 8. If 3 will get you 2 here for using oxygens, but we have 6, we've multiplied the recipe by 2 in regard to oxygen, right? So if 3 will get you 2, then 6 will get you 4. 6 will get you 4. Choose the one that's possible. Again, the small number is the one that's possible, so we'll choose 4. So we made 4 SO3s. Now, which one is the excess reactant? It's the one, maybe you crossed this out, that we crossed out, or the one that we would have extra of. We have sulfur enough to make extra product, right? So we have too much sulfur, we have extra sulfur, it is the excess reactant. So it is the excess reactant. So this is the reasonable number. We will run out of O2. We'll use up all 6 atoms to make the 4 SO3s. We can only make 4 of them. We can't make 8. So what we're saying is we have enough sulfur to make extra SO3s, which means we have extra sulfurs that we won't be using. That's why it's the excess reactant. It is the one that has extras and will have atoms left over. So we made 4 SO3s. We're going to jump back and find out the number of atoms used of the excess reactant. If we made 2, we used 2. So if we made 10, we used 10. If we made 4, we used 4. Also, we're going to formalize that by putting the 2 over 2. 2 of these and 2 of those. Of course, they cancel out, and we get 4 atoms used of the sulfur. Well, how much is left over? Well, we know we used 4 then, and we started with 8. Starting with 8, using 4 leaves 4 atoms left over. So what remains total? We just said there are 4 atoms of sulfur left over. When you make the 4 SO3s, obviously that's 4 of those, and you used up all of the oxygen, so there is 0. On 4, what will be in the beaker? Well, let's look at the F2s. 1 of these can make 2 of those, so 6 of these can make 12 of those. It's double whatever you just said for this one. 2 of these will get you 2 of those, so it's the same number. So 4 of these will get you 4 of those. Choose the one that's possible. Again, it's a small number. We're going to cross out the 12 probably. Now, let's consider this also, though. 2 of these will get you 1 of those. So this is half as much as you put in. But I'm putting in 4, remember? If I'm putting in 4, I can make 2 Cl2s. How many HFs can we make? 4. That's a reasonable number. We can't make 12. The big number is always wrong. So we have F2 such that we can make extra product. That means we will have extras of these left over. It is the excess reactant, and it's the one that we'll have extras of. So how many HFs can we make? 4. What's the excess reactant? F2. If you made 4, you must have used 2 because 2 needs only 1. So say 10 would need 5 and 20 would need 10, and 4 will need 2. It will use 2. So 4 made of these used 2 of those. Here we have it again. This is the number used. What did we start with? 6. 6 F2s we started with. We just said we used 2, and that leaves 4 left over. So what remains? We just said there are 4 F2s left over. When we used up all the HCl, that leaves 0, because when we make 4 HF, we mean that we'll use all that up. And we said we will make 2 Cl2s, and we said we will make 4 HFs. On 5, we want to know the mass of the product that can be made. So we have 10 grams of this and 30 grams of that. So we're going to jump in each case from the reactant to the product and then choose the reasonable one. So we're going to go from the grams to the moles. We put the grams on the bottom so that we can cancel out the grams. And the molar mass of H is 1, but we have 2 of them. So the total molar mass is 2 grams per mole. Then there are 2 of these we're going to get for every 3 of those. So it's 2 of these and 3 of those. The 2's cancel out, and we get 3.33 moles of product possible. Well, how many moles is 30 grams of N2? The molar mass of N on the periodic table is 14, but we have 2 of them. So that's 28 grams overall per mole for the N2. That cancels out the grams. And we're going from here to there. So that's 2 of these and 1 of those, 2 of these and 1 of those. Multiply by the top, divide by the bottom, and we get 2.14 moles of product possible. Choose the one that's possible. It would be that one. Big one is always wrong. So we can make this many moles of the product. The molar mass of N is 14. Molar mass of H is 1 on the periodic table. So we have 14 plus 1, 1, 1 is 17. That lets me cancel out the moles and gives me grams of the product.